Hello, future toppers. Let's make maths simple, intuitive, and fun together. So, we got wholesome new session of this differential equation where we guys have already covered variable separable method and its three transformations. And then we have studied linear differential equation and its one transformation. And then now we have to cover homogeneous differential equation. So first try to understand what is homogeneous differential equation. Homogeneous equation, okay? So these equations will carry means every element will have same power. Okay, if you'll observe every element is having same power, you can say that it is homogeneous differential equation. Okay, and these straight lines, it is derived from straight lines. So many straight lines passing through origin. If you'll multiply, you will have every element carrying same power. Okay, so for example, suppose look at this question. So 2x square, so x square means what? Variable is carrying x square, so degree is 2 for this element because x is carrying 1 power, y is carrying 1 power, so altogether this element will carry 2 power, y is carrying 2 power. So this is a homogeneous differential equation. Okay, so how will you respond to these kind of questions? So the idea is you have to do nothing, just replace x with y with vx. That's it, and you will understand each and everything. Okay, so you have to replace y with vx. Now look at this, how I will approach this question. So if a curve y equals y of x satisfies the differential equation this 2x 2x square dy equals 2xy plus y square dx. So this is the differential equation and it passes through this. Okay, now look at this. So how we will respond? So first I will assume that like we have to apply the filter named variable separable method. So we will try to segregate variables, but if you'll observe, you cannot segregate them because all x cannot put together, all y cannot put together, and both of them cannot be put in product, so you cannot segregate them. Then we will apply the filter of dy by dx equals to linear function, which is not true, it is quadratic by quadratic. Then we have dy by dx equals to linear by linear, where the sum of coefficient of y from numerator and the coefficient of x from denominator sum up to 0. It is not either. Then we have polar thing where we have taken x dx plus or minus y dy. We cannot observe that thing over here. Then we have second filter, that is linear differential equation, which look like this: dy by dx plus y, and then here p of x, here q of x. You cannot convert that thing into that form. Okay, now what we should do? So we have to apply like upgradation of that. Here we have assumed y power n, it is not of this form either. So what we will do, we will apply homogeneous differential equation. So how does homogeneous differential equation look like? So first we will write dy by dx. Look at this, dy by dx, and we have 2xy plus y square and then 2x square. How will you say that we can apply homogeneous differential equation? Because this thing is carrying power 2, this thing is carrying power 2, this thing is carrying power 2, so every element is carrying power 2, so same power. So we can apply this idea, homogeneous differential equation. So what we have to do to these questions, we have to replace y with vx. That's it. Now do the differentiation with respect to x. So we have dy by dx is equal to, we will keep v as it is, dx, x ka differentiation is 1, and then x dv by dx. So this is my idea. Okay, now can I replace this dy by dx with that thing? So we will have v plus x dv by dx is equal to 2 times, in place of y we have to write vx. So v x and x square, vx square plus v square x square, and then we have x square. So if you'll observe, you can take x square common and neutralize it. So you will be having 2v plus v square and then by 2. Okay, now if you will observe, you can apply variable separable method. So first what I will do, look at this, can I write this thing as v plus v square by 2? So this v gone, so we are left with x dv by dx equals v square by 2. So if you'll observe now, you can apply variable separable method. At the end, every question will be converted into variable separable only. So we can write dv by v square is equal to dx by x2, and then we have to apply integration. Okay, so it is v power minus 2. So what we will do, v power minus 1 by minus 1 is equal to 1 by 2 log x plus integration constant c. You can write this thing as 1 by v. Okay, now you know that you have given question in the form of x and y, not u and v, so you have to replace this v. So who is v? V is y by x. So can I write this thing as minus of x by y is equal to 1 by 2 log x plus c. So this is our function. Now to find out the value of this integration constant c, we will be using this idea. As the curve passes through 1 comma 2, it will satisfy 1 comma 2. Okay, 1 comma 2, in place of x we will put 1, in place of y we will put 2. So it is minus of 1 by 2 is equal to, log 1 will become 0, so value of c is minus of 1 by 2. So the required value of c will become this, minus of x by y is equal to 1 by 2 log x minus 1 by 2, or you can multiply both sides by minus, you will be left with this function. So we got this thing, this is the proper function we have. Now what do we want? We want f of 1 by 2. Now we have to replace x with 1 by 2. So it is 1 by 2y is equal to minus of 1 by 2 log 1 by 2, can I write 2 power minus 1, and that minus 1 will become at coefficient plus 1 by 2. So can I multiply both sides by 2? This thing, this thing, this thing. So can I write 1 by y is equal to log 2 plus 1? Okay, in place of 1 can I write log e? Log e base e is 1. So log m plus n is log mn 2e. Okay, we are supposed to find f of 1 by 2. So f of 1 by 2 will become reciprocal 1 by log 2e. I hope the idea is clear and you guys can handle similar situations. So see you guys in next session of MathFlix.